Hello children, welcome to aimstoday online classes. In today's video, from math subject, lines and angles topic we are going to continue. Our today's concept is regarding parallel lines children. We are going to learn about parallel lines today. So what are parallel lines? We can take the example of two straight rails of railway track. The two rails of railway track are example for parallel lines. Two straight rails of railway track, or two sides of a straight road, or as you see in this picture, the parallel bars used in gymnastics, used by the gymnasts in the gymnastics. These are all examples of parallel lines. Parallel lines means two lines in a plane that do not intersect. If they intersect with each other, they will be called as intersecting lines. But two lines which are lying in the same plane, though they are extended in any direction, but they never intersect, that kind of lines are called as parallel lines. So here, two lines are two line segments in a plane which do not intersect, and the perpendicular distance, if you observe the perpendicular distance between the parallel lines, between the two lines, if the perpendicular distance between them remains constant at any point, then they are called as parallel lines. So here we have a line L and we have another line M. This is the perpendicular distance at one instant. This is the perpendicular distance at other instant. Both are perpendicular distances, but both are same. Both the magnitudes are same. So this L and M are called parallel lines, and this two straight line symbol is the symbol for parallel lines, and it is read as parallel to. Line L is parallel to line M. Like that we have to read. Next children, we have about transversal. So transversal is also a kind of line. Transversal is nothing but it's a kind of line that cuts across, or we call it as intersecting. The line that intersects two or more lines in distinct points or different points, that line is called transversal. If you have two or more lines, like this LM are two lines here, this LM are two lines here, LM are two lines here, here LMN, three lines are there, here also LMN, here also LMN, three lines are there, here also LMN, three lines are there. So in first diagram, second diagram, third diagram, we have three lines, L, M, N. Here also L, M, N. Here also L, M, N. Three lines are there. So in figure 1 and 2, line N is the transversal with reference to L and M, because it intersects the lines in two distinct points P and Q. So the line N intersecting L at P, intersecting M at Q, means it is intersecting two lines at two distinct points or two different points. So this N is the transversal of L and M. In second figure also, this is L and this is M. This N is intersecting L line at P and M line at Q at two distinct points. This N is an example of transversal. Whereas in the third case, this is line L this is line M, but the N line, it is intersecting both the lines at one common point. So it is not the transversal. It is not the transversal. Okay. Next. So here in figure 3, it is not a transversal. Why? Means it intersects two lines at one point, at only one point. So that's why it is not transversal. So next, a point A may be selected on the transversal. A point A may be selected on the transversal, and the 3 points Q, P, A can be read in order in which they appear on the transversal. In which they appear on the transversal, like this. So here A point we have taken here. So this is read as QPA. Here A is taken this side. A is taken this side. It is we can read it as AQP. AQP. Or in third figure, we can read it as QAP. Like this, we can take any point on the transversal along with the two other points. The third point also should be read in order. In what order they are appearing, in the same order we have to read them. But if you observe figure 1, 2 and 3, there is a small difference. If you observe carefully, so this A point in the first diagram, it is outside this PQ region. In second diagram also, it is outside PQ region, but it is inside the PQ region. So here, so A is said to be in the exterior region with reference to L and M, because A is not between P and Q. If A is outside P and Q, we can tell that A is in the exterior region of the transversal, because it is not lying between P and Q. If it falls between P and Q, then we have to tell it is in the interior region with reference to L and M. So we can divide the regions of transversal. It is the exterior region. So outside this PQ portion, outside this LM lines, whatever portion is there, that is considered as exterior region, and the middle portion between L and M is considered as interior region. So interior region, and this will be the exterior region. This side also will be the exterior region. So the point, it may be in the exterior region or it may be in the interior region. Next one, angles formed by a transversal. So when two straight lines are cut by a transversal, special pairs of angles are formed. So already we have learnt about adjacent angles. We have also learnt about vertically opposite angles. We have learnt about linear pair. About some pairs of angles already we have learnt. Here, based on transversal concept, we are going to learn about some more special pairs of angles. So here, AB is a straight line, CD is a straight line. These two are the straight lines. These two straight lines are cut by the transversal PQ at two different points. At one point, this side, angle X. At one point, this side, we have angle Y. These two angles are equal. Means the angles which lie between the two lines and on opposite sides of transversal in the interior region, which lie in the interior region are called as alternate angles. Alternate angles. Here, XY are alternate angles. XY are alternate angles. In the same way, we can take this. Suppose if this is A, this is B, AB are another pair of alternate angles. Means this total region is interior region. So in the interior region, opposite sides of transversal. Transversal this side, transversal that side, up and down. So these two are considered as alternate angles. One pair is XY, another pair we can take AB like that. And another pair, so here this pair, this XY pair, they are called corresponding angles. Means they lie on the same side of the transversal, above the transversal, and same side of the transversal. So if they correspond to the same position at both intersecting points, above the transversal, then they are called corresponding angles. Another pair, we can take this one, below the transversal A, below the transversal right side B, or we can take this pair C, above the transversal left side, CD, or linear pair, or EF, below the transversal on left hand side, EF, like this. We can take the corresponding angles. So next, they are called corresponding angles. Next, we have co-interior angles. Co-interior angles means they lie in the interior part of the transversal, and on the same side of the transversal. So here X, Y, same side of transversal, like this. A, B, like this, co-interior angles. So here children, alternate angles means opposite sides of the transversal. Okay. So here we have three types: alternate angles, corresponding angles, co-interior angles. These three are the special pairs of angles based on the concept transversal. Alternate means they lie on opposite sides of transversal. Corresponding means they lie on same side of transversal, either above transversal, below transversal. Co-interior means they will lie in the interior part of the transversal, in the on the same side. So here children, let's see the angles here according to this diagram. Interior angles, this 3, 4, 5, 6, these are all interior angles. These are all only interior angles which are lying in the interior part of the transversal. They are not pairs of angles, single angles. 3, 4, 5, 6. These 4 angles lie in the interior part of the transversal. Next, exterior angles. 2 is lying outside the line. 1, 8, 7. These are all individual angles, are considered as exterior angles. Exterior angles. These 2 angles are not pairs of angles. They are individual angles. Next, pairs of alternate angles. Alternate angles means 3 and 5. Lying in the interior part, lying on the opposite side. One that side, one this side. 4, 6. 3, 5 and 4, 6 are pairs of alternate angles. Next, corresponding angles. Pairs of corresponding angles. 2, 6. 26, 37, 37, 15, 48. Right side above side, right side below the transversal. Left side above the transversal, left side below the transversal. We have 4 pairs. 4 pairs of corresponding angles. We have only 2 pairs of alternate angles. Pairs of alternate exterior angles. Alternate exterior angles. These 4 are alternate interior angles. Alternate interior angles. Sorry. This 3, 5, 4, 6 are alternate interior angles, whereas this 2, 8 and 1, 7 are alternate exterior angles. These are alternate interior angles. These are alternate exterior angles. So altogether, these 2 pairs plus these 2 pairs, 4 pairs of alternate angles we have, but 2 are interior, 2 are exterior. Next, co-interior angles lying in the interior on the same side. 3, 6 are co-interior, 4, 5 are co-interior. Next one. So test your understanding here. Line P is transversal to the lines L and M. Name the following. So here line L, M are 2 lines and P is the transversal between them. We have to name the angles. 2 pairs of alternate angles. 2 pairs of alternate angles. These 2 are the lines. This is the transversal. Transversal above in the interior. Transversal below in the interior. 7, 6. So angle 6, angle 7 are pair of alternate angles. In the same way, angle 3, angle 2. Angle 3, angle 2 are pair of alternate angles. 4 pairs of corresponding angles. Corresponding angles. Corresponding angles means 1, 3, 7, 4, 8, 6, 2, 5 are corresponding. A pair of interior angles on the same side of transversal. Same side of transversal. A pair of interior angles means co-interior angles. 7, 3, 1 pair. A pair of exterior angles on the same side of transversal. Same side of transversal, but exterior. 8, 5 are same side, but exterior. These 2 are called co-exterior angles. Co-exterior angles. 8, 5. Refer to the figure, name the alternate angles. This is one line, this is one line, and this is the transversal. Alternate angles. Transversal this side, transversal this side. 5, 3 are alternative, 2, 6 are alternative. Alternate angles. Corresponding angles. 8, 2, 9, 3, 5, 10, 6, 11 are corresponding angles. Next, vertical angles means at the same point, vertically opposite angles. 8, 6, vertically opposite. 9, 5, vertically opposite. 2, 11, 10, 3 are vertically opposite angles. Co-interior angles. Co-interior angles. Co-interior. 5, 2, co-interior. 6, 3, co-interior. Next, refer to the figure, fill in the blanks. Angle 2 and dash are alternate interior angles. Angle 2 and dash are alternate interior angles. 2, 8. Angle 2 and angle 8 are alternate interior angles. Next, angle 2 and dash are interior angles on the same side of transversal. Same side of transversal. 2, 5. Interior angles on the same side of transversal. Angle 2 and dash are corresponding angles. Angle 2, transversal downside. Corresponding angle 6, transversal downside. Same side. Angle 2 and angle 6 are corresponding angles. Angle 2 and dash are vertical angles, vertically opposite. At the same vertex, opposite angles. Angle 2 and angle 4 are vertically opposite angles. Okay, children. Remaining topics we can learn in our next video. Thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. You can also visit our website, children, www.aimstoday.in for other information. Thank you, children. Have a good day.